Okay, today we're gonna do integration by parts. So let's see. Suppose we want to integrate the following functions. Well, I guess before we're gonna go ahead and see where the integration by parts formula comes from. So here we go. It comes basically from the product rule. And the product rule is basically when you take two functions, f times g, and you take the derivative of these two functions, of this product. So using the product rule, you get first function, you leave it alone, you take the derivative of the second function, then you take the first function and take the derivative on it, and then you take the second function and you leave it alone. Then you integrate both sides of this equation with respect to x. So then on the left hand side you just get f of x times g of x, and on the right hand side you just get the integral of f times g with respect to x plus the integral of f prime times g with respect to x. If you reorganize this, you eventually get something that will look like this: the integral of f of x times g prime of x dx equals to f of x times g of x minus the integral of f prime of x g of x dx. And then if you let u equals f of x and v equals g of x, then du will be f prime of x dx, and dv is g prime of x dx. So then plugging in this into the previous equation, you just get the integral of v du, because we have f, which is u dv, not v du, so it's a good thing that I checked. So u dv, and then this will be equals to uv minus v du. And this is the famous integration by parts formula that we're going to be using in the following examples. Alright, the first example we're going to do, I'm going to take the integral of x times cosine of x dx. We're going to let u equals to x and dv equals to cosine of x dx. So then by doing that, this will be u dv, and by the integration by parts formula, this will be uv minus v du. Alright, we gotta find du from here. So if u is x, then du is dx, and v is integral of cosine, so that's sine. Okay, so then uv would be u, which is x, and v, which is sine of x, and then minus the integral of v du, where v is sine of x and du is dx. So then we have x sine of x, and the idea of integration by parts is so that this integral right here is hopefully easier to integrate than the original integral. As you can see, it does not have an x, so it's easier to integrate. You just integrate sine and you get minus cosine, but because of that other negative sign, you have plus cosine of x. And then let's see. Alright, now suppose we have something like the integral of x squared times e to the x with respect to x, and we want to use integration by parts. So we're going to let u equals to x squared my pen doesn't want to write, come on, got it, x squared, and the v will be e to the x dx. Alright, then this will be u dv, which will be uv minus d du. So we gotta find du here, which is 2x dx, and we gotta find v here, which is just the integral of e to the x, so this will be e to the x. So then we have uv, which is x squared times e to the x, minus v, which is e to the x, but du is 2x dx, so go put 2x right here dx, and this integral right here is still gonna need integration by parts, so this is sort of like called integration by parts 2 times. So x squared times e to the x minus, this is just gonna be uv minus v du using integration by parts again, where this time u is 2x and dv is e to the x dx again. So then du here will be 2 dx and v will be e to the x. So then this will be equals to x squared times e to the x minus u, which is 2x, v, which is e to the x, minus the integral of e to the x times 2 dx, and then integrating that, finally we get x squared times e to the x minus 2x e to the x plus 2 e to the x plus c. So this is called integration by parts twice. Whenever you have an integral like this that we just did, x squared times e to the x dx, if one of the functions dies out when you integrate, and you can easily when you differentiate and you can easily integrate the other one, then you can use something that is called tabular integration. And the tabular integration basically goes like this: you put the two functions side by side, so in this case x squared and e to the x, you put them side by side, you differentiate on this function f, which would be 2x, and you integrate on this function. Then you differentiate again on 2x to get 2, and then you integrate on e to the x to get e to the x, and then you differentiate one more time on 2 so to get 0, and then you integrate e to the x to get e to the x. Then what you do, you're going to multiply x squared times e to the x with a plus sign, and 2x times e to the x with a minus sign, and 2 times e to the x with a plus sign. So basically you start with a plus sign and then you switch. And then this guy and this guy have to be left alone. This is called tabular integration. So then this guy right here is just going to be the product of x squared times e to the x and 2x times e to the minus e to the x minus, so minus 2x times e to the x, and then plus 2 times e to the x, and then plus c. So this is the same as what we obtained before using tabular integration. So this tabular integration works whenever one of the functions dies out when you integrate, and the other, when you differentiate, and the other one is easily integrable. All right, integration by parts. Whenever you want to integrate a definite integral. So suppose that you have this integral from 0 to 4 of x times e to the minus x dx. Okay, this is basically, they want me to find the area of y equals x times e to the minus x as x goes from 0 to 4. So if you graph this function, it'll go something like this, and then blah blah blah. It will never touch that x-axis, but from 0 to 4, oops, this would be basically this area right here, and that's what that integral is. Alright, it turns out that this integral right here requires integration by parts, so I'm going to go ahead, even though you can do tabular integration, I'm just going to go ahead and do integration by parts so that you can see what the process is whenever you have a definite integral. That means when you have limits. You still let u equals x and dv equals e to the x dx. Then you have to find du, which in this case is dx, and then v, which is e to the minus x. So e to the minus x, but this is going to be minus e to the minus x, like that. Then this time you're going to have uv, but then you're going to have the limits from 0 to 4 minus v du from 0 to 4. That's the only new thing. You have limits. So u, again, in this case is x, and v is e to the minus x negative, so I'll put the negative right here, and then this goes from 0 to 4. Minus the integral from 0 to 4 of v du, where v is e to the minus x negative, so this will be a positive, and then du is just dx. And then you just integrate that last integral, so you get minus x and it's e to the minus x, like this, from 0 to 4. And then you integrate that e to the minus x, so you get minus e to the minus x, like this, from 0 to 4. And now that you have them together, you can just go ahead and say this is minus x times e to the minus x minus e to the minus x from 0 to 4, and like this. So you put them together, and then you just put the limit. So we put 4, you get minus 4 e to the minus 4 minus e to the minus 4, like this. And then you put 0, and then you get 0 minus e to the 0, so 0 minus 1. So this is minus 4 e to the minus 4 minus e to the minus 4 plus 1. So 1 minus 5 times e to the minus 4. Okay, this is integration by parts for indefinite and definite integrals. Thank you very much.